This is an enrichment of a pulse upload on rectilinear motion. It focuses on two situations involving constant acceleration, one of which is on the effectiveness of airbags in preventing fatal injury to passengers during a car crash. How is the concept of constant acceleration related to collision? Find out, stay put, watch and learn. Question number 1. During a car accident, the vehicle's airbags deploy slow down the passengers more gently than if they had hit the windshield or steering wheel. According to safety standards, airbags produce a maximum acceleration of 60 g that lasts for only 36 milliseconds or less. Question is, how far in meters does a person travel in coming to a complete stop in 36 milliseconds at a constant acceleration of 60 g, assuming the car has an initial speed of 80 kilometers per hour? Let g equal to 9.8 meters per second squared. Airbags are cushions that are inflated extremely quickly upon impact and subsequently uh, de- depleted to protect passengers during a collision. They provide a soft restraint between the occupants and the vehicle interior during the crash, which can reduce or even prevent injuries. So our solution to this problem, we first identify the given data, right? We have the acceleration produced by the airbag, which is 60 g, or 60 multiplied by 9.8 meter per second squared, that is equal to 588 meters per second squared. We also have the uh, time elapse, all right? The time elapse of 36 milliseconds, which when converted to seconds is 3.6 raised to the negative 2 seconds. All right, so the acceleration produced by the airbags will cause the buckled occupant, meaning it is assumed that the driver or the passengers is or has fastened his seat belt. All right. So the airbag will cause the buckled occupant, specifically his or her head and chest, to slow down more gently from an initial speed of 80 kilometers per hour, all right, which is equivalent to 22 meters per second, uh, to a final speed of zero in just a fraction of a second, or 36 milliseconds, all right, in this case. So our target variable is delta D, which is the stopping distance for the car occupant, or the driver could also be the passenger. Whatever is the force associated to this very high acceleration, all right, it would not cause an injury on the occupant as compared, for example, as compared to hitting the windshield or the steering wheel directly if there is no airbag or airbags, and seat belts combined. All right? So using the kinematics formula, delta D equals B naught multiplied by time T minus 1 half AT squared. We want to know how far the occupant's head will move towards the steering wheel, all right, or the dashboard in the given specified elapsed time of 36 meter second. Sorry, 36 millisecond. All right. When the airbag produces that maximum acceleration of 60 g before it stops. All right. So in this formula, we will plug in the given quantities. Okay, 22 meters per second. That is the initial speed of the car, and hence of the what do you call the driver's upper body multiplied by the time 3.6 raised to the negative 2 seconds and minus 1 half of the acceleration 588 meters per second squared and multiplied by the square of the time 3.6 raised to the negative 2 seconds. So doing our math, we will get the value of delta D, all right, 7.92 times 10 to the negative 1 meter is the result of multiplying 22 meter per second by 3.6 times 10 to the negative 2 seconds. And that's minus, all right, the result of multiplying 1 half times 588 meter per second squared and the square of 3.6 times 10 to the negative 2 seconds, which is 3.81 times 10 to the negative 1 meters. All right. And that gives us um, the value of delta D, which is 4.11 raised to the negative 1 meters, which when converted to its normal form, that's equivalent to 0.41 meters. So our calculated distance, all right, for a car driver or passenger is very small, all right, or has a very small value, which suggests that the airbag indeed prevents a possible collision between the passenger's head and chest, okay, and the windshield or steering wheel, right? For our last question, question number 2, you're standing at rest at the bus stop. A bus moving at a constant speed of 5.00 meters per second passes you. When the rear of the bus is 12.0 meters past you, you realize that it is your bus. So you start to run towards it with a constant acceleration of 0.960 meters per second squared. Question is, how far would you have to run before you catch up with the rear of the bus, and how fast must you be running then? For our solution, we identify the data, such as your acceleration starting from rest, or v naught equals 0. All right? Our target variable is delta D. All right? Delta D is the distance that you need to run to catch up or overtake the bus, which had just passed you and moving at a constant speed equal to 5 meters or 5.00 meters per second. All right? And when you started running, all right, the bus is actually 12 meters away from you already. All right? So, before we can calculate for delta D, all right, we first compute for the time t. All right? The time t is the time it takes you to overtake the bus from initial time 0. All right? And so okay, our equation now becomes delta D equals 1 half 80 squared, where the delta D is in fact equal to D plus 12 meters. Right? So D plus 12 meters, of course, is equal to 1 half the acceleration and the square of the time, which when we substitute, all right, we have 1 half. The acceleration is 0.960 meters per second squared multiplied by the unknown variable time t. Okay, that has to be squared here. All right. So isolating the distance d from this equation, we will isolate the distance d and come up with the first equation, equation 1. D equals 0.48 t squared minus 12. All right. Now, this variable or unknown variable d is in fact the distance traveled by the bus during the elapsed time of t. All right. So d equals bt is the equation that we use for describing the distance traveled by the bus during that time elapsed t with a constant speed. All right, equal to 5.00 uh, meters per second. All right, and that will be multiplied by the same variable for time small letter t, and we call that our equation number 2. All right, so if we are going to equate the two equations, since they both have the variable d, combining them, we will get 0.48 t squared minus 12, all right, that's equation 1, equal to 5.00 multiplied by t. And dividing all the terms by 0.48, all right, we will get, all right, a quadratic equation, t squared minus 10.4t minus 25 equal to 0. So this will be our working equation for determining the variable time small letter t. This quadratic equation for finding the variable t can just be worked out using the quadratic formula. All right. So the quadratic formula, which is t is equal to negative b plus minus square root of b squared minus 4ac all over 2a. In our equation, b refers to the second term, all right, which is in this case negative 10.4. All right. While A, of course, refers to the numerical coefficient of t squared, which is understood to be 1. And then C refers to the third term, which is negative 25. All right. So uh, we can now use this quadratic formula, all right, to find the variable t. So just follow the formula, and we have uh, negative b, all right? But since 10.4 is understood to be negative, all right? And the formula says negative, so negative, that becomes 10.4, all right? Plus minus square root of the square of b, which is 10.4, square it, then minus 4 multiplied by 1, which is the numerical coefficient of t squared, and c, which is negative 25. Then all over 2 times a, or 2 times 1. And simplifying, okay, so what we did here is to first uh, determine the result of getting the square of 10.4, and that is equal to 108. Then also the product of 4 times 1 times negative 25, all right? Okay, so the value inside the radical sign, okay, 108, okay, plus 100. Then that will be divided by 2. Further simplification will give us t equal to 10.4 plus minus, all right? The sum of 108 and 100, of course, is 208. So we get the square root of that, all right? Then we add 10.4, all right? Then the result will be divided by 2, all right? Now, the other possibility, theoretically speaking, is when you subtract 10.4 minus the square root of 208, let's first uh, write down the result of getting the square root of 208, and that is 14.4. So, when you do the subtraction, that is 10.4 minus 14.4, it will give you a negative value, all right, which will result to a negative value for the time t, all right, which in this situation uh, doesn't make any sense. There's no such negative time. So we will just consider adding 10.4 plus 14.4, then divide by 2, all right? Our result, okay, is that the value for the time t is equal to 12.4 seconds. So, since what we are looking for is the distance, okay, that you have to travel or you have to run in order to overtake the bus, all right? Uh, Equation 2, okay, compared to equation 1 is a much easier equation to determine the value of d, all right? Because we will just multiply the calculated time, 12.4 seconds, and the speed of the bus, 5.00 meter per second, all right? So substituting, we'll get 5.00 meter per second times 12.4 seconds, and we will get the value for the distance d equal to 62 meters. All right. So earlier we said that this D, all right, is the distance traveled by the bus during the time elapsed equal to 12.4 seconds. And the question is actually asking for the distance that you need to run in order to catch or overtake the bus. All right? So, what we do is just add to 62 meters, we will have to add 12 meters. All right? So, 62 plus 12 meters, which is 74 meters, will give us our final answer. This is the distance that you need to run in order to overtake the bus. At least you will be uh, abreast with the rear of the bus. All right. And likewise, at that instant, all right, after 12.4 seconds, when you're already uh, at equal, what we call displacement as the rear of the bus, we are also asked to determine your maximum speed. Okay, because you are running with a constant acceleration. That means from initial speed of 0, okay, what will be your final or maximum speed? Okay, the moment you catch up with the bus. So we use the formula or equation to find the final or maximum speed equal to uh, the product, your acceleration A, and the time elapsed T. That is, we just multiply the acceleration or your acceleration 0.960 meter per second squared multiplied by the time elapsed 12.4 seconds. And we will get the value for your maximum speed, all right, equal to 11.9 meters per second. So that is the speed or your maximum speed when you overtake the bus, all right? So how do we evaluate these answers? We say that this maximum running speed is relatively very high or very fast, all right? And the distance that you need to run is such a long distance, 74 meters, all right? And it appears that you need to run this distance just for 12.4 seconds, okay, with such a high speed, all right? An average senior high school student, we say, is not physically able to accomplish this. Don't you think so? But if you are an Olympic sprint champion, like Jamaica's Usain Bolt, then this is just a piece of cake. All right, so that completes our tutorial for this episode. Till the next video tutorial, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.